Okay, so this is a continuation of what we have learned earlier today. So kita akan discuss balik pasal itu direct current generator and also alternating current generator. So someone asked me, what is the difference between induced current and induced EMF? I think most of you juga wondering what is the differences between these two quantities. So induced current, so ingat kalau the word induce means we don't use battery. Instead, we use relative motion to produce the induced current or induced EMF. So induced current is the current that is induced in a conducting loop that is exposed to a changing magnetic field. So like what is shown in this figure, as you can see, the magnet that is moving towards the solenoid or moving away from the solenoid is the changing magnetic field. So it will create an induced current in the loop or in the solenoid and make the galvanometer punya pointer deflect either to the left or to the right. So itu adalah induced current. Okay, so itu adalah induced current. For induced EMF also known as electromagnetic induction or EMF induction is the production of voltage in a coil because of the change in a magnetic flux through a coil. Okay, so an EMF can be induced in two ways. For example, when an electric conductor is kept in a moving magnetic field, or when the electric conductor is constantly moving within a static magnetic field. Macam apa yang kita sudah bincang, like this one lah. Ini adalah the coil is in between a static magnetic field. So this is one way to produce the induced EMF in a generator, right? So later on, I will post this one in your group so that you can refer back the differences between these two quantities. Okay. So yang tadi itu juga we stop at yang video apa tuh AC generator kan. So I think we should look back at the video, the ones that I have shared in your group instead of the one yang kena bagi dalam itu buku teks tu lah, yang deep voice tu kan. So kita tengok balik lah itu video. Hold on. Semua kamu sedang makan nggak? Atau sedang makan depan screen? Diet? Kenapa belum makan? Mother not home yet? Alah. Aduh, janganlah diet nanti. Wait, stop sharing this one. So more handsome.
Grammarly can help you write quickly and confidently, so you never have to slow down at work. Stay on top of email, documents.
From B1 to B2.
Astaga, wait. Not this
now,
one.
During the next half rotation, arm AB moves.
Dia punya music tu lain-lain. Ini ya.
Is from north to south pole.
I start again. This one.
Hi and welcome back to my YouTube channel. In this video, we will talk about the AC generator. AC generator is an electric machine that converts mechanical energy to electrical energy in the form of an alternating electromotive force or alternating current. AC generator works on the principle of electromagnetic induction. So when we have relative motion between a coil and a magnetic field, an electric current or electromotive force is induced in the coil. Let's look at the basic components of AC generator. Armature is part of an AC generator, which carries a current and consists of many coils of wire. Armature converts electrical power to mechanical power in the form of torque and transfers it via the shaft. Shaft is movement part and it's connected to armature. Field magnet consists of two poles, north and south pole. Field magnets are concave and cylindrical shape and therefore produce radial magnetic field. Direction of the magnetic field is from north to south pole. Slip rings S1 and S2 are connected to the armature and rotate together with it. The slip ring consists of a circular conducting material that is connected to the armature rotor windings. Slip rings are used to bridge, transfer, and carry the power to and from the rotor of an AC generator. Brushes B1 and B2 are usually made of carbon. One end of each brush is in contact with rotating slip ring and the other end is connected to the other circuit. Galvanometer is connected to outer circuit. Purpose of galvanometer is to show the flow of current in the external circuit. Furthermore, we will explain the working principle of the AC generator. When the armature rotates between the poles of magnetic field, armature cuts the lines of magnetic field and generates current in the coil of armature. This induced current then flows through the circuits connected to the armature. In fact, it flows through the armature, slip rings, brushes, and through galvanometer, in which we have a response. As you can see, galvanometer needle swings between negative and positive values. This means that alternating current passes through galvanometer. When current is induced in the armature, it's necessary to know the direction of that induced current. So initially, armature coil ABCD is in a vertical position. Armature part AB is up while part CD is down. As you already know, direction of the magnetic field is from north to south pole. Undergo half rotation in clockwise direction, part of armature AB goes down while part CD goes up. According to Fleming's right-hand rule, the thumb indicates the direction of movement of the armature part CD. It is in fact direction of the force, which is upwards. First finger points direction of magnetic field from north to south pole, and second finger shows direction of induced current. In our case, current will flow in direction DCBA of armature and from brush B1 to brush B2 through galvanometer. If we take another half rotation, part of armature AB moves up while part CD moves down. Again, according to Fleming's right-hand rule, the thumb indicates the direction of movement of the armature part CD. It is in fact direction of the force, which is downwards. First finger points direction of magnetic field from north to south pole, and the second finger shows direction of induced current. In our case, current will flow in direction ABCD of armature and from brush B2 to brush B1 through galvanometer. To conclude, induced current changes direction for every half rotation. Next thing we need to see is how induced EMF changes over time. To see this graphically representation of induced EMF, we have to assume that armature needs t seconds to complete full rotation. In time, t equals 0 seconds armature, ABCD is in a vertical position. Part of armature AB is up and part CD is down. Part of armature AB and part CD moves parallel to the magnetic field at that moment. Also at that moment, the rate of change of magnetic flux is 0, Therefore, induced EMF is 0. For the first quarter rotation, from t equals 0 seconds to t over 4 seconds, part of armature AB moves down and part CD moves up. In this period, induced EMF increases from 0 to maximum value. In t over 4 seconds, armature is in horizontal position in relation to the magnetic field. In t over 4 seconds, rate of change of magnetic flux momentarily gain maximum value. Therefore, the induced EMF at this position is maximum. During second quarter of rotation, from t over 4 seconds to t over 2 seconds, part of armature AB moves again down and part CD moves up. In this period, induced EMF decreases from its maximum value to 0. In t over 2 seconds, armature again is in vertical position. Part of armature AB is down and part CD is up. Part of armature AB and part CD moves parallel to the magnetic field at that moment. Also at that moment, the rate of change of magnetic flux is 0. Therefore, induced EMF is 0. During the third quarter of rotation, from t over 2 seconds to 3t over 4 seconds, part of armature AB goes up and part CD moves down. In this period, induced EMF increases from 0 to maximum value. But in this period, induced EMF has opposite polarity. In 3t over 4 seconds, rate of change of magnetic flux momentarily gain maximum value, but compared to a position in t over 4 seconds, induced EMF gain its negative value. Finally, during the last quarter of rotation, from 3t over 4 seconds to t seconds, part of armature AB goes up, part CD moves down. In this period, induced EMF decreases from its maximum negative value to 0. In time, t seconds armature is in a vertical position. Again, armature is moving parallel with magnetic field. Rate of change of magnetic flux is 0. Therefore, induced EMF is 0. From this graphical representation, we saw how induced current changes in time. As you probably already know, the term AC, or alternating current, generally refers to a time-varying waveform or sinusoid, and we saw that sinusoid in this graphical representation.
Woo! Adapted my
Doi. Terus ada iklan. Okay. So, wait. So how was the video just now about the AC generator? Boleh paham? Or we still need to discuss dia punya working principle tuh? Oke. Tapi better kita bincang lagi lah kan step dia one by one. Supaya kamu betul-betul paham tuh. Oke. Mau bincang lah ini. Sebab alright. Okay, so this one daripada my previous notes during KBSM punya about the DC generator and also AC generator. So kita tengok step by step lah kan. For yang DC generator, I don't have to explain dia punya parts in the DC generator. Yang penting dia ada apa tuh? Dia ada split rings. Ini adalah split rings and ada carbon brush and also commutator. Okay, and then the coil of wire is rotating in the magnetic field. So a function of the commutator is to reverse the connection of the coil with the external circuit after every half cycle. Okay, apa yang kamu mesti paham dulu yang ni nanti, every half cycle. What is meant by every half cycle? Bila itu half cycle tuh? Bila dia akan jadi half cycle? When the coil is in what position? now the coil is in a horizontal position kan. So bila itu yang dikatakan sebagai half cycle. Okay, bila dia dalam keadaan vertical, right? Bila dia dalam keadaan vertical. Okay, so we look at the step yang sana dalam itu DC generator one by one. Okay, so in number one, yang step number one dulu kan, yang ni we look at this one first on the left hand side. So coil AB, kita tengok tu movementnya di sana tu, the rotation is anti-clockwise. Okay, the rotation is anti-clockwise. So coil AB, this part here, will move downwards. Okay, coil AB will move downwards and coil CD will move upwards. Now, how do we determine itu dia punya rotation itu clockwise ataupun anti-clockwise? How do we determine dia punya direction of rotation itu? By using what rule?
Right hand rule.
Ya, memang kalau dalam induction, we always use yang Fleming's right hand rule to determine dia punya direction of the induced current. Okay, so ini Fleming's right hand rule kita guna dalam ni induction to determine direction of the induced current. So kalau dalam ini dia punya diagram, ngam ka tu dia punya direction itu di sana? Ngam? Semua tidak sure. Nama, tapi yang ada silap dia di sini nih. Kamu tahu apa silap dia? Coba kamu tengok. Kalau kamu guna itu your Fleming's right hand rule kan. Okay, the direction of the induced current is correct from B to A, and then balik pi sana D to C. Even the rotation or direction of the movement of the coil is correct, anti-clockwise. Tapi apa yang salah di sini? Did you notice? Is the position of no, not the force. Is the position of the magnetic poles correct? Kalau kamu guna itu, kamu punya Fleming's right hand rule, bolehkah kamu punya your index finger itu pointing to the correct direction of the magnetic field, not to south? Dapatkah tidak? Coba kamu try. Ini kan dia punya magnet. This is the magnet di sana. Not to south. But then, kalau kamu punya Fleming's right hand rule, ikut itu directionnya lah kan, your index finger is pointing to the right. And then your your thumb is showing the direction of movement, which is anti-clockwise. Sama ada dia pergi up ataupun down. Ngam kah? Cek dulu. Itu dia punya diagram. Semua ngam? Each part, sebelah kiri dengan sebelah kanan. Ngam dia punya direction of F? F is down. Sebelah mana? Which part? Left or right? Okay, I was just testing you guys. Memang betul lah dia punya direction. The direction is correct. Okay, to determine dia punya direction of the movement, you have to put your right hand on both sides, on left and also on the right. Okay, so ngam dalam ini diagram, the direction of F, the arrow pointing downwards and also upwards. Okay, so memang ngam. I was just testing you guys. Okay, so ini sudah. So when number 2, when the coil rotates, its sides cut across the magnetic field lines and induced current flows in the coil from B to A and D to C. Okay, so it means that in this position, dalam ni position the vertically with the magnetic field, the magnetic flux is cut. So if there is a cutting of the magnetic flux, induced current will flow in the coil, and there will be a deflection on the galvanometer. Now the deflection of the galvanometer will follow the direction of the induced current. Jadi ngam lah kan dia punya direction of the deflection of the galvanometer pointing to the right because it follows direction of the induced current. Okay, so it is pointing towards left. Ngam. Okay, next step number 2. So when the coil rotates, so now it will be in a horizontal position. Dia tegak sudah, vertical position, vertical position. So the sides AB and CD are moving parallel. So maksudnya di sana tuh moving parallel is, they left out this one bah, the magnets. So now the magnetic flux can go through the coil without being cut. Okay, there is no cutting of magnetic flux, so there will not be any induced current produced. So the galvanometer will return to the center, which is 0. Okay, yang ini paham? Dia punya konsep tuh. When it is in a vertical position, the magnetic flux can go through the coil without being cut. So no cutting of magnetic flux means no induced current. So there will not be any deflection on the galvanometer. Yang itu paham? You think so, Faiz? Masih lagi bingung yang ini? Oke, tidak apa. Dia akan terus tuh. Oke. Step number 3. Step number 3. So masih juga, this is the magnet. I drew the magnet here. Okay. So it is now in a horizontal position again. horizontal position, but the sides AB and CD already interchange. So dia rotate kan, so dia punya sides or is interchange sudah. Alright, so now the current will still flow in the direction from CD and then A to B. And direction of current, direction of the induced current, when it flows through the galvanometer, it will still deflect to the right because it follows the direction of the induced current. Now in step number 4, it is now in a vertical position again. So when it is in a vertical position, what happens is the magnetic flux can go through the coil without being cut. So no cutting of magnetic flux, no induced current is produced. So the galvanometer stays at the center without any deflection. Okay? Boleh? Now, ada satu lagi, why there is no deflection on the galvanometer in step number 2 and number 4. Okay, kamu tengok itu dia punya position of the slip rings. Ini, the position of the slip rings. It is not in contact with the commutator and the carbon brush. Not in contact tuh, yang sini nih. It is not in contact with the carbon brush and the commutator, so the circuit is now incomplete. Incomplete, so there will not be any current flowing in the circuit. So that's why the pointer of the galvanometer stays at the center without any deflection because no induced current is produced. Compared to the first one. Yang ini dia punya slip rings, as you can see, dia punya slip rings is in contact with the carbon brush and the commutator. So the circuit is completed and induced current can flow in the circuit and there will be a deflection on the galvanometer. Okay? Itu okay kan? Now let's look at the graph produced by the DC generator. Kita tengok apa graph dia yang akan terhasil. So this is the graph that is produced by a DC generator, direct current generator. Okay, one thing kan yang kamu perlu ingat di sini, untuk direct current generator, the current flows in one direction only. Okay, it flows in one direction only. Why one direction only? What is meant by one direction only? Anyone can give any answer on that one? What is meant by it flows in one direction only? Apa maksud itu? When you look at this graph, what does it means by the current flows in one direction only? The current only going one direction. Yeah, which direction is that? By looking at this graph, the direction that we are referring to is apa? Positive or right? Positive. Okay, it only flows in the positive direction. Yalah, in the upper part. Because at this part here, ini kan, ini part is the positive direction. Forward motion. And this part here is considered as negative. So that's why untuk yang DC generator, it says that the current flows in one direction only. So means there only flows in the positive direction. Okay, forward sahaja. Going forward. Alright, going forward. So, okay, so kita tengok on how to get dia punya graph itu. Good. We start with the first position. Okay, we start with this first position, number 1. First position, the coil is in a vertical position. So vertical position, will there be any deflection on the galvanometer? Will there be any induced current on the galvanometer? No, yes. Tidak ada. Because apa? Ya, itu apa tuh, slip rings is not in contact with the carbon brush and the commutator. So the circuit is not completed and there will not be any induced current flowing. So that's why it will start here. Okay, I put an X there to mark a 0, the value 0. Okay, in that position, 0. And then as it rotates, what will happen is the value of the induced current will increase until its maximum value. And then when will that be maximum? At what position will the induced current be maximum? It will be when it is in a horizontal position like this, number 2, 90 degrees. Okay, 90 degrees. 90 degrees, the value of the induced current will be the maximum. Because that position will be when the cutting of the magnetic flux will be the maximum. So that's why the reading on the deflection of the galvanometer will be the highest. Okay, and then as it rotates again, so the value of the induced current will start to decrease. It will gradually decrease until it is in a vertical position again, like in number 3. Okay, in vertical position, the slip rings is not in contact with the carbon brush and the commutator again. So circuit is incomplete. No induced current is produced in the coil. So there will not be any reading or deflection on the galvanometer. Okay, so that's why dia akan jadi 0 again. And then it will continue to rotate again until it is in a horizontal position, 90 degrees, another 90 degrees. So the reading on the galvanometer will be the maximum. And then rotate lagi until it is in a vertical position. So itu adalah 0 lagi. Okay? Yang ini boleh paham, the graph and the position of the DC generator and the graph. Can you understand this one? On how to get the shape of the graph like that. Can I? Right. Hopefully can lah. Okay. Number 4, number 5. Okay, now let's look at AC generator. AC generator, the difference between AC and DC generator is yang ini AC generator, it doesn't have split rings. Dia tidak guna split rings, but instead it will use slip rings, and masih lagi ada carbon brush to complete the circuit. Okay, to complete the circuit. Right. So the picture there shows an AC generator invented by Tesla. So that was the earlier model of AC generator invented by Tesla. Yang kita guna sampai hari inilah. Okay. Now the two ends of the coil are connected to two slip rings which rotate with the coil. Each slip ring is always in contact with the same carbon brush. Kalau yang tadi itu DC generator, dia punya split rings is it doesn't stays in contact with the same carbon brush because every time it rotates, dia interchange kan? The interchange. The split rings will be in contact with either the left punya split ring, carbon brush, or on the right hand side of the carbon brush. So dia tidak sama. But this one untuk AC generator, the slip rings will always be in contact with the same carbon brush. Same carbon brush. Okay, same carbon brush. Now kita tengok how the movement is. Okay, number 1. In step number 1, kalau kita tengok sini, dia punya rotation is still going anti-clockwise. This is still the magnet. Okay, there's the magnet, curve shape, concave shape, curve, concave shape, magnets. What is the reason why we use curve or concave shape magnets? To produce radial magnetic fields. Yeah, betul. Okay, now the movement of the induced current in the coil, as the coil AB moves downwards, coil CD will move upwards. And then when the coil rotates, its sides cut across the magnetic field lines and induced current flow in the coil from D to DCBA. So itu dia punya direction di sana lah, DCBA. By using Fleming's right hand rule. Okay. Coba kamu tes kalau ngam ataupun tidak dia punya direction itu by using your Fleming's right hand rule. Is it correct? Correct, huh? Okay. Yes. Correct direction. Okay. So in the external circuits mean it is referring to this part here. This is the external circuit yang ada P dengan Q that connected the slip rings to the carbon brush. So the current will flow from P to Q. So when you are required to draw the deflection on the galvanometer needle or pointer, so you show it like this one. Okay, it is deflected to the left. Now do not draw the deflection of the galvanometer like this one. Jangan lukis begitu. So there must be a deflection. Sebab galvanometer punya bentuk, the zero is sini kan? So this is the pointer. This is the pointer of the galvanometer. So you shouldn't be drawing the arrow like this one. So there mesti ada deflection sedikit ke sebelah kiri ataupun sebelah kanan. Okay, so don't draw like this one. Okay, and then the second one, the sides AB and CD, are moving parallel to the magnetic field and thus do not cut the magnetic field line. So again, like the previous ones in DC generator, when it is in this position, the magnetic flux can go through the coil without being cut. So no induced current is produced and the galvanometer returns to 0 mark. Okay, so dia akan jadi beginilah. Returns to 0 mark. Macam juga yang DC tadi itu. Okay, now the third one. Third one, after the vertical position, the current increases until it attains the maximum value when the coil is in a horizontal position. Now, coil CD moves downwards, coil AB moves upwards. And direction of the induced current is from bagaimana? CD. Kemudian BA, AB. Can you see dia punya path flow sana? The connection of the coil with the slip rings. So the induced current will flow from CD and then go to here and then Q to P. Q to P and then through this slip rings going to the other side and then A to B. Dapat? Yeah. So the direction of the current through the external circuit is from the branch Q to P, which is reverse. So dia punya pointer on the galvanometer is pointing in this direction. Okay, and then step number 4. In step number 4, so again, it is in a vertical position. So the sides AB and CD are moving parallel to the magnetic field and thus do not cut the magnetic field lines. So they go through sesenangan. No induced current is produced at the instant the galvanometer returns to 0 mark and the process is repeated. Okay, so far, any problems with this working principle of the AC generator? Any problem on this one? No problem. Okay, next dia punya graph. Okay, so graph for AC generator, because the word alternating kan, alternating means back and forth. Back and forth. The signal will be back and forth. Unlike DC generator, which only flows in one direction only, which is the positive direction. So AC generator, it goes both ways, positive and also negative direction. Okay, both ways, huh? So the output current that generated AC generator is an alternating current because the current changes direction in the external circuit each time the coil passes the vertical position. Assume the current flows from P to Q is positive. And the current flows from Q to P is negative. Okay, P to Q we assume as positive direction and Q to P is negative direction. The current changes the magnitude and direction after every half rotation. Okay, so we start with this position number 1. In position number 1, because it is in a vertical position, so no cutting of the magnetic flux. So dia punya reading on the galvanometer will be 0. And then as it rotates, the value of the induced current will increase until it is in the maximum position like this, number 2. Okay, itu adalah maximum position. Now the current, the induced current is flowing from, it is flowing from C to D and then P to Q. Kemudian pergi ke A ke B. Now, dia sudah mention tadi, if the direction of the induced current is from P to Q, so we assume it as a positive direction. So that's why it is drawn in the upper part. The graph is drawn in the upper part, indicating that it is a positive direction. Okay, and then as it continues to rotate, the value of the induced current will slowly decrease until 0. Until 0 because it is in this vertical position again. No cutting of magnetic flux, no induced current is produced. So the reading is 0 again at this part here. And then as it continues to rotate, so the value of the induced current will also gradually increase until it is in the vertical, horizontal position like in number 4. So now the current that flows in the coil is from B to A and then pergi ke mana? Dia limpas pergi sini Q dulu. Dia limpas pergi sana Q and then going to P and then back to D and then C. So this one, dia punya direction is from P to Q. This one is Q to P. Direction is Q to P, so we consider that one as a negative direction, moving in the negative direction. Okay. Then dia punya apa tu? The coil continues to rotate until it is again in the vertical position. So dia punya reading again will return to 0. Alright. So dia punya, the shape is sinusoidal. Graph of sinusoidal. This one okay? Any problem with this one? Boleh-boleh lah. Hopefully, not so many questions asked about this one during exams. But still, you have to know how to get this type of graph. Mesti tahu lah. Okay, because after this electromagnetism punya chapter is electronics. Lagi advance lah. So mesti tahu juga lah kan how to get this type of graph. And itulah hopefully not so many questions asking about this. Adapun mungkin yang selalu keluar kalau yang KBSM is in essay, the working principle of a direct current generator ataupun AC generator. That one kan macam not so famous, but I don't know, not so popular, but I don't know if Cikgu Hilda will test that question for your third exam, because she will be doing that question, the question for your exam, and usually dia akan bagi soalan yang bukan favorite punya lah, ya. Yeah. So I was afraid if ini yang kena kasih keluar. So itulah penting juga we go through this one lah. Okay? Supaya you guys know how to get that graph. Okay? Any question? Hopefully tidak ada. So I will post this one also in your group for you to refer back. Because kan in your workbook, I've already checked in your workbook. Yang ini, this one is in your workbook, page 119. Got some explanation juga. Maybe you can go through that one. Same thing like what I have just explained. Okay, you can just go through that one. But apa ni? I prefer using this diagram because they are macam clearer and bigger instead of the ones in your workbook. Hopefully it helps lah. Hopefully it helps. Okay, now in your textbook also we have covered this one. Now let's look at the differences and similarities between DC generator and also AC generator. So ini the similarities, both applies electromagnetic induction. Coil is rotated by an external force. Coil cuts magnetic flux. EMF is induced in the coil. Now the differences between DC generator and alternating current generator is, for DC generator, the ends of the coil are connected to a split ring commutator. While the AC generator, the ends of the coil are connected to two slip rings. For DC generator, the two sections of the commutator exchange contact with the carbon brush every half rotation. Exchange contact. Okay, the exchange contact. This is to ensure apa nih? Maybe you can apa? The reason is to ensure current flows in one direction only. Okay, so that is the reason why the commutator exchange contact with the carbon brush every half rotation, to ensure that the current flows in one direction only. So that's why they punya graph, the ones that we saw just now, is like this one. It's like the sinusoidal graph. Itu bahagian yang negatif tu kan, dia kena modulus. Kena modulus, so it will become positive. Okay, dia akan jadi positif di sana. And the output is direct current lah. For AC generator, the slip rings are connected. Slip rings are connected to the same carbon brush. Same carbon brush, so that's why dia punya rotation itu, the connection is not interchange, and it is able to flow in both direction, whether positive or negative direction. So the output is AC. So itu dia punya differences and also similarities for AC generator and DC generator. So actually we have covered this part. Sudah habis untuk yang electromagnetic induction. So the next topic will be transformer. This is the last subtopic in this chapter before we go to electronics. And in the transformer, actually you have learned these basics there in Form 3. In Science Form 3. Got some part yang ada ini topik transformer lah in Science Form 3. So this is just a continuation of what you have learned in Science Form 3. Okay. Any question for AC generator and DC generator before we end our session? Exactly 9 p.m. Tidak ada, no. What about the others? Any question? Terry bilang tidak ada, Faiz bilang tidak, Ryan bilang tidak. No question. Okay. No question. So yang tidak dapat join ni malam is Judith because she have tuition, and also siapa lagi ya? Farena, tidak. Farena ada masalah connection bahkan kalau malam. Okay. Bah. Oh, if no more question, then that will be all. So I see you guys again tomorrow morning. So make sure you guys attend all your classes, ha? Hindi ka na sound lagi po nga to. Bah, that's all for tonight. Thank you.
Thank you, teacher.
Okay.
Thank you,
Thank you,
teacher.
teacher.